जाइए काफी जाइए शुरू से। Bhagalpur from BC Bhagalpur in FDP microeconomics. Thank you, my coordinator sir, sir, to give me the opportunity to participate in FDP program in artificial intelligence and machine learning in BC IEEE BC Bhagalpur. In this, I'm going to give a short notes and lecture on image processing, digital image processing. At first, we know what is digital image processing, a digital image. We have a lot of things to know that images are not only in digital or digital format of image. When we need the relevant documentation or further process or for more information for the scientific process, then we need the digital image. And digital image is in the format through which we segregate and format in different form or and higher level. In the primary or lower level, the image are in only in the form of image. But in the middle level, the image are in the form of pixel and that we convert in the attributes. So for segregation and for further process. For other process and for more or performance and for other process for recognition that it is like artificial and learning, then we apply the high level image processing to the software and different type of user software. Thanks for listening. Next.
Good evening, all of you. My name is Bharat Kumar. I am student of MTech in Technology Bhagalpur. Thank you, Janif sir, to express myself in front of FDP. In this time, agriculture is daily life. The basic need of human being in the case of agriculture, AI also helps in many kinds of tools, help in the field of agriculture, like help in the field of agriculture. AI technology helps detecting disease in plants, pests, and poor nutrition of farms. AI sensor detects and target weeds. The ultimate goal is increasing the quality of crops and safe from insects. AI is used in the field of crop and detect intelligent spraying. Behalf of the agriculture, AI is used in healthcare. AI enhance preventive care and quality of life, produce more accurate diagnosis and treatment, and lead to better patient outcomes overall. AI used in healthcare are to find the accurate cancer. Agriculture analysis help to predict the condition of crop and soil. AI gets sowing app. Our government also helps in the field of agriculture, such as many Kisan Yojana and Agriculture Udan. Finally, AI is the future of agriculture or innovating of AI in agriculture. Thank you very much.
रिकॉर्ड हो रहा है ना वहाँ पे देखो।
Good evening, all of you. Myself, Ravikant, Triple IT Bhagalpur, and tech student. Today, I am speaking how we can use machine learning in any agriculture field. Like that, how to predict the crop for according to our uh, soil type, like that, temperature type, in which how many attributes we can use to select the crop. Like that, in which how many attributes we can use, like that, in soil condition, how much potassium is there, phosphorus is there, and humidity, like that. The main objective of this is our project, that to predict to some pattern in data, like that only, in which we can use different type of sensor, like that humidity sensor that sense the humidity. Means in the environment, like that, we can predict the humidity with the help of humidity sensors, and soil sensors, like that only. Okay, sir, thank you.
नेक्स्ट है ये
थैंक यू सर। हाँ मार्केट So good evening all of you. Myself Nilofar Pathak. I am assistant professor in Jail Bazaar Institute of Engineering and Technology, and also I am the research scholar in IIIT Bhagalpur. Okay, so in between these related to the machine learning and the deep learning like ANN, CNN. But before that, we are going to the algorithms part and different algorithm like SBM or CNN, ANN. But one thing is that what is an algorithm? First of all, we have to know that because CSC background already knows that about the algorithm. तो एक सिंपल लैंग्वेज में हम बात करते हैं, ठीक है, कि एल्गोरिथम है क्या। सबसे पहले क्या बात है, जब हम एल्गोरिथम डिजाइन करें, चाहे आप एसपीएम डिजाइन किया है, चाहे आप सीएनएन, किसी ने भी डिजाइन किया होगा, उस डिजाइन को हम क्या कर रहे हैं, हम अपने वर्क में क्या कर रहे हैं, जस्ट एक इंप्लीमेंट कर रहे हैं, सिंपल। हमने एल्गोरिथम डिजाइन नहीं किया। आप ये बात को ध्यान दीजिए, जब भी आप रिसर्च एंड नॉलेज जो हम बात कर रहे हैं, कोई भी चीज आपने क्या किया, आप प्रेडिक्शन कर रहे हो या क्लासिफिकेशन कर रहे हो, जो भी आप परफॉर्म कर रहे हो, उसके अकॉर्डिंग क्या कर रहे हो, जस्ट एक एल्गोरिथम वो लिखा हुआ है, हमने अपना डेटा सेट ले गए, उस एल्गोरिथम को फॉलो किया और उसके अकॉर्डिंग वो हमारा बन गया। बट द मेन रिसर्च इज दैट ना, यदि आपको इन फ्यूचर, यदि सीएस बैकग्राउंड से मैं रिक्वेस्ट करूंगा कि हाँ, इसमें एक रिसर्च ये हो सकती है कि एल्गोरिथम, उस एल्गोरिथम से नया एल्गोरिथम कैसे डिजाइन कर सकते हैं। अब एल्गोरिथम डिजाइन करने के लिए दो चीजें आपको ध्यान देनी पड़ती है। पहली होती है टाइम कॉम्प्लेक्सिटी, दूसरी होती है स्पेस। दो चीजें आप जब भी एल्गोरिथम का डिजाइन करोगे, दो चीजों की बहुत ज्यादा जरूरत होती है आपकी। एक होती है टाइम कॉम्प्लेक्सिटी, दूसरी होती है स्पेस कॉम्प्लेक्सिटी। स्पेस कॉम्प्लेक्सिटी आज के टाइम में ज्यादा इफेक्टिव नहीं कर रहा है, बिकॉज ऑफ दैट कि आप सबके पास जो भी सिस्टम होगा, आई डोंट थिंक सो कि आपके पास 1 टीबी से कम स्पेस होगा किसी के भी लैपटॉप में या सिस्टम की बात करें तो स्पेस कॉम्प्लेक्सिटी की बात नहीं। लेकिन जब भी हम डेटा सेट की बात कर रहे हैं, जैसे अभी मॉर्निंग में हम बात कर रहे थे कि 20,000 डेटा सेट के लिए हमारे लिए 8 जीबी कम से कम मिनिमम रैम चाहिए, तो हम जाते हैं जीपीयू के लिए, वो क्लाउड हमें परफॉर्म कर रहा है, तो स्पेस कॉम्प्लेक्सिटी खत्म हो गई है। अब नेक्स्ट बात आती है टाइम कॉम्प्लेक्सिटी। जब आप एल्गोरिथम्स को डिजाइन करने जाओगे, लाइक कि एसबीएम से रिलेटेड, एसबीएम में कुछ ड्रॉबैक होंगे, ठीक है, एएनएन में भी कुछ ड्रॉबैक होंगे, उसके अकॉर्डिंग क्या होती है, दो चीजें होती है। जो एल्गोरिथम्स होती हैं दो टाइप से होती हैं, एक होती है आपकी पॉलिनोमियल टाइम की एल्गोरिथम होती है, दूसरी होती है नॉन पॉलिनोमियल टाइम की एल्गोरिथम होती है। पॉलिनोमियल टाइम और नॉन पॉलिनोमियल क्या है, एक सिंपल से एग्जांपल से मैं बता के एंड करूंगा लेक्चर को, कि एक पॉलिनोमियल बाइनरी सर्च, आई थिंक कंप्यूटर साइंस सबको पता होगा, बाइनरी सर्च की टाइम कॉम्प्लेक्सिटी क्या होती है, ऑर्डर ऑफ log n। बाइनरी सर्च की आपकी टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ log n होती है। ऐसे ही हम जब एक और एल्गोरिथम की बात करते हैं, लाइक डिजास्ट्रा की बात करें या ट्रैवलिंग सेल्समैन की बात करें, ये एल्गोरिथम आपने पढ़ा होगा, तो उसकी और टाइम कॉम्प्लेक्सिटी क्या होती है, 2 की पावर n। इस टाइप से आपकी सारी जो होती है वो तो ये जो होती है ये पॉलिनोमियल टाइम, इट मींस दैट कि पॉलिनोमियल टाइम में खत्म हो जा रही है, इसमें चेंजेस नहीं कर सकते, बाइनरी सर्च को आप चेंज नहीं कर सकते। उसी तरीके से जब हम मशीन लर्निंग के डिफरेंट एल्गोरिथम्स की बात करते हैं, इसमें चेंजेस हैं, इसमें भी अभी रिसर्च बहुत सारी बाकी है। तो आप एल्गोरिथम्स को जो जितने भी एल्गोरिथम्स आपने पढ़े उसमें रिसर्च आप कर सकते हो कि उस एल्गोरिथम को और एफिशिएंट हम कैसे कर सकते हैं, जिससे और हमारे प्रेडिक्शन लेवल चेंज कर सकते हैं। हम उस एल्गोरिथम को नो यूज कर उसको हाइब्रिड कर दें या कुछ मिक्स करके इस तरीके से हम कर सकते हैं। थैंक यू।
नेक्स्ट हो गया ये हमारे रोगिंग बच्चे हैं, रोगिंग का नहीं हुआ है, रिसर्च को नहीं हुआ। चलो कौन आप जाकर फोन करो ना, इसका तो सारा प्रॉब्लम है। नहीं दिया तो हमारे पास एक पैरामीटर हो गया कि नहीं दिया तो ये क्रेडिट में 20% मार्क्स है इसका ग्रेड सी देना तो सबको है।
Hello, my name is Robin Newton, and I am from IIT Bhagalpur, doing my MTech first year. I'm in MTech first year. So I'm going to talk about one machine learning algorithm called KNN. So here it goes. KNN algorithm is based on distance search, distance mapping. What it does is, if we want to classify, let us suppose this is two class data. If we want so it uses Euclidean distance to classify these two class of data. How it does is, the Euclidean distance is summation of xn minus xt square, where n equals to 0 and t equals to 0 up to any number of data we want, where n is not equal to t. So this is how it does. What it does is, if you want to, if we define a k, suppose 3, which is the distance that we take, and this when we take we don't know what the class label of this data is. If we want to know which class this data belongs, then what we do is we calculate the distances between all the data points from this new data point. If suppose this distance is 1, this distance is 2, and this distance is 3, this distance is 5. So what we see is 1, 2, 3 are the distances which are very closer to this cross class. That means the new data belongs to cross class. This is how KNN algorithm works. That's all. Thank you very much.
Good evening, everyone. Good evening, sir. Myself, Divyanshu Prakash. I'm an MTech student here in first year. So today, I'm going to tell you about a little the different types of association rule mining. I'm going to tell you about one, that is a priori algorithm. What is association rule? In this, we associate one thing with others. Like if one thing is happening, then the other thing is also happening. Like if generally we use this in transactions. Like if a customer is buying one thing, then he's also buying that second thing with the first thing. So here we and confidence. We here let's take, we have 4 transactions: transaction 1, transaction 2, transaction 3, transaction 4. Here people are buying 4 products, that is like say egg, bread, milk and juice. Let's say here let's say there are four customers who are buying these different things. So here we will define this parameters before, that support should be around like 50% and confidence should be 75% when we find the association rule here. So what is support? Support is nothing but frequency. If I am buying egg, so how many times, how many customers are buying egg? Like if here 3 customers are buying, no, only 2 customers are buying egg, so its frequency is what, only like it's happening only 2 times in total, four transactions. So here let's suppose we define support is 50% at first. So we will find support of each and every product: support of egg, support of milk, bread, and jam. Two by four, that is 50%. Bread, next, first, second is milk. 1, 2, 3, 4. 4 by 4. So like here, we can say that, we can see that all the products are lying under, under this. All the products are qualified that they have supports equal or greater than two products, like combined of 2 products, like egg with milk, egg with bread, egg with juice, and egg with jam. So like this, we will also find the support of milk and bread, milk and juice, milk and jam, and bread and juice, bread and some products have supports less than 50% and some products have support more than 50%. So there, those who have support more than 50%, then we will find the confidence for those products. The formula for the confidence is if we are finding the confidence of X and Y, then the support of X and Y together upon my support of X. Like this, we will find the confidence. If their confidence are greater than 75%, X is egg, then Y is bread, and the confidence for egg and bread over egg. If customer is buying egg, then he is also buying bread. So like this, the malls or what shops use this kind of things, the big shops like shopping malls, to arrange their products. Like if they are arranging egg in this place, then they are arranging that together besides that. So thank you. Bhagalpur. And for today's teaching practice event, I'll be giving an overview of one of the projects I did in my previous semesters. Just clean this up. So the topic for my project was predicting mental health for employees of tech and non-tech companies. So what it basically was, I took a data set from open source from Kaggle. So that's a website name. No one knows about it. There's a website name. So there was a data set about employees in tech and non-tech companies. So as we all know, in these times there's a lot of stress and people are suffering from depression and all kinds of mental health problems. So I was interested in what I did is downloaded this data, and I'm just going to describe what kind of data it was. So there were around like 84 questions asked to around almost say 800 people. So for each person, you were asked a lot of questions like what is your name, what is your gender. So I'll just write it down. So we have age, gender, what kind of company they were working in, so like tech or non-tech. Then came some questions about like mental health. Mental health, whether your company was providing you with mental health options, like if you're suffering from it, were they talking about it, or whether they were providing provisions for it, and what were they doing to combat the situation. So there were a lot of questions like these, and it was asked to around like 800 people. So I was going to use this data set, and I had to choose. These are called attributes, right? These are features that you must have learned in the previous sessions. So I had to choose some of them because space and resource consuming, and also it's like it's not worth it because some of them would be very trivial and wouldn't help in predicting whether the person is suffering from mental health or not. That's why that was my objective, to predict whether if I ask you some particular amount of questions, I was going to predict whether you are suffering from mental health or not, mental health problems or not. So now comes a part of selecting those features. So there are a lot of mathematical ways where you can select those features. I went a different route. selected particular set of features. I'm not going to name that right now, but they were like more like family history. You had whether you have a history of mental health or not, and some more personal questions. So out of those, they were like 7 features of, and my 8th feature was the class label, whether you have the mental illness or not. So using those 7 features, I'll be predicting the class label. Then comes a part in doing such projects that is called pre-processing. You can say it was not like a standard data, so there were a lot of missing values. So how I was going to address this, I will tell you that. So for example, let's say there was one thing called gender. So we know, like in this time, like it's not just binary. A lot of people who are saying they're transgender, non-binary, there's LGBTQ, so all that. So I had to like we have to put it into a numerical format so that the machine could work on it. So that was one part I did. Then there were some missing items. So we use just basic mathematical tools like interpolating. So what's the maximum amount of majority of what people are saying, and just interpolated those items. So that's how I completed the whole data set. And then finally comes a part of making the model. So before that, you split the model. So as even sir said today, %. For sorry, this is for training, right? Sorry, I made a mistake. So this is for training, and 30% is testing. It's like the golden rule, so you can use that. So after this, I use around like 6 machine learning algorithms. I could name some like KNN. One of the participants also explained this before. There was Bayes, logistic regression, and many more. So like there were 6 of them. I ran those tests, ran those algorithms on this dataset after splitting, and compared those their results. And finally, in my case, it came out to be name-based. So one of this was the algorithm that came on top. So and then I could finally deploy my project. So what we do is after finally making the model and the model is predicting according to your preference. If you're satisfied with it, you can use web apps or Windows app, or you can make it anything. So I use a web development web app which you can open on your browser. So you just had it was like a little website that you can open on your browser, and you were asked some questions on predict whether you had mental health issues or not. So that was my project. Thank you.
तो प्रॉब्लम जी तो चाय बिस्कुट खाओ और चलते हैं रिकॉर्डिंग और खाने डिनर पर आप लोग आ जाइए। कल हम लोगों का लास्ट है, अभी हम लोग आपको